table concept, internal table and external table. So this all informations I will explain you there in practical part in my Hive cell external table. First we'll see internal table and then we'll see external table. How to identify this belongs to which table, and second option, that how can I open a cell of Hive. So open Hive cell or Hive terminal. To open this Hive cell or terminal, you will have to write in this Hive or sudo Hive. If this is not working, you can type sudo Hive. So when you type this Hive, automatically the terminal of Hive will open. I'll do that in my Cloudera. Here, sudo Hive sudo basically for admin access, right? If there is any access issues in Hive cell, I can get all the access using just this sudo command. This will take a while to open Hive cell. No, this will, currently I'm using Cloudera, right? So I'm using ready-made environment. That's why this is there. But if I'm setting this by myself as in I'm doing manually, then I will have to download this from here. Hive download. This is an open source system, open source software. You'll have to go to index link of this Hive and download and set up in your local machine, as in your Ubuntu or manual system. Okay, but we are using Cloudera, that's why this is already inbuilt. And those setup parts are more into admin, so I don't want to go to the setup part of Hive and other thing. We'll use the ready-made thing, and this is why I'm moving to Cloudera and using this Cloudera for all the practicals. Now, all this query which I'm going to run is related to databases, especially RDBMS. Can I run so databases? When I run this so databases, I can see database which are present in Hive. Now Hive is having just one by default database, so I'll create one for me for my table creations. Let's say create database and database name, which is PRWA. Once this database is created, you can check again using so databases command. It will list down all the databases right here. After that, you can use this database same as MySQL and create this table inside, create the table inside this database. Can we check so tables? Obviously it will give us 0 because there is no table existing currently. Now next operation, I'll create one table and I want to store one single row which is a text data in that column. and my table definition is as follows. I'm going to write currently a detail statement. Here I will say create table. Now when you're writing external table, difference I will tell you when to create internal table and when to create external table. But if I'm not writing external keyword here explicitly, then this is the internal table. If I'm removing this, this is a by default internal table, which Hive will manage. So create table, table name, and I'll give table name as book. I'm just giving one dummy name, and then dummy as my column name. This is say string, and I just want to store one row, so I will give here semicolon. The moment you give semicolon, this is a termination. Your line will be executed. Now enter, and this took me 0.72 second, less than a second, to complete the query. Now can I check this table again? I can see the table. This OK is just an acknowledgement. So book table is there, and I will describe this. Dummy and string. So dummy is my column name, string is my data type. Now how to write the data, and where is this metadata stored currently? Okay, where this metadata is getting stored. So this metadata is getting stored in MySQL, and that setup you want to see. Where is that setup? Because if you are interested to set all these things manually by you should know this point, and that's what I'm telling you currently. The file name where we configure all Hive related properties is inside this directory, usr lib hive slash conf configuration. Inside this folder, I will see all the files. User lib hive conf, things will be there inside this. So let's go and see how many configuration values we can see inside the Hive configuration file. Remember guys, whenever you're setting anything, this is the location, main location. We keep all the folder inside this because this can only be accessed by root user or admin. This is the reason we keep things inside slash usr slash lib. I'll go to that directory and say cd user lib hive, and I'll directly go to conf. This is the same directory. Can I use pwd user lib hive conf, and I will use lslrt. When I'm using lslrt, I can see hive site.xml file. By default, when you download Hive from Apache, so this file name is hive default .xml .template, something will be there. So you'll have to make that file, give just a name that hive site.xml, okay, because that's what Hive community recommend. Hive site.xml, can I open this hive site.xml and see what properties are added in this? So this is the main configuration area for Hive. You're not doing this manually, this is all set by default. Just for your knowledge, I'm talking about the configuration. Connection URL. Connection URL is, this is going to MySQL database. This is the IP address. This is the meta store where all the metadata will store. Okay. And create database if not exist, we are giving as true. So if this is not created, create it. If this is already present, do not create it. Okay. Just like if exist, we say that in a statement in our RDBMS. If exist, do not delete that table. If do not exist, delete the table. Sorry, If exist, delete the table. If do not exist, create the table. That command we define. What is my driver name? My driver name is JDBC MySQL driver. What is my connection username? That I have given as Hive. What is the password? That is Cloudera. Then few other thing. Where is this meta store connecting URIs? This is for Spark connectivity. We'll come to this part later when we talk about Spark, because Spark has given one module, one option to developer that using Spark SQL, I can access, I'll repeat, using Spark SQL, I can access Hive table. I can access Hive data. Okay, let's do that. So I'm going to see my my meta store, and where is my metadata getting appended or created. Because this metadata is going to MySQL, that's why the MySQL connection is required, because I need to store metadata somewhere. We know two things, right? Hive is storing data to HDFS and metadata to some database. And we have seen 3 points there in metastore: local metastore, embedded metastore, and remote metastore. Now, embedded metastore was Derby by default. But if I want to open a multiple session, I need PostgreSQL, Oracle, MySQL, this metastore. In Cloudera, by default, this is MySQL currently. Not necessarily you'll have to use MySQL only. You can change it to Oracle, Postgres, or somewhere else. But I need some metadata to keep my column values, data type, and few other information. Let me go to MySQL now. What is the command to go to MySQL? This is MySQL u root p. And password, you have seen there, password is Cloudera here. So password is Cloudera. And now I'll run tables. Or before tables, I'll say so databases. What was the database name? Metastore. Can I use this database? Can I check the tables? So many tables, but I've already queried on all this table and checked where is my information getting appended, and that's the table name. Select star from TBLS. Select a star from TBLS. The moment I say select a star from TBLS, can you see my table name book is there? My table name book is there. This is the internal table. That's why this is known as a managed table. Okay, internal table is also known as managed table. So we can refer this name interchangeably. Internal table. Now, how many columns we have? Okay, we have just one column. Any other information? Just this information. Now, if I start creating the table, all that information will start getting appended in this TBLS. We'll revisit this again when we create new table and see how the metadata is getting stored. You can see this is your metadata of your Hive table. Now, after checking this, I'll go back to my Hive cell, and this time I want to write some data. I want to load some information there. And when I want to load some information, I'll open another cell, another terminal. So currently I'm writing all these things in this cell because I feel this cell is bit faster than Workbench or UI. After completion of this, I will visit Hue, HUE, and there I will show you all the editable options. Like Hive cell, you can manage from there also. That is good for beginner. Okay, if you get a good hands on there, then you can come and start writing queries. So let me write it here, then I will visit Hue part and show you how you can write the same query there that is giving you some user friendly environment. The interface is friendly, you can see things well, but just to get the things more faster, I'm using this terminal currently. I want to load the data, and I will have to create the data first. So this is my cell. Here I'll say, let's say create a table. Okay, so we say cat sample.txt. Hey, this is Hadoop, this is Hive testing. Presently Hive is terrific warehousing management option provided by Facebook. I've written this text statement, enter, and control D to terminate the line. If I use lsrT, I can see this sample.txt and get this data. Now big question. Okay, this is good. I can create the file, but this is a unstructured information. This data is unstructured. Text data comes under unstructured category. Now, how can I handle this? I can easily handle this in Hive. I'll store this whole data in one column. How? So there are two operations given by Hive to their community developers, and this option is as follows. I'll write it here in this first. If I want to load, so let me put the title. If we want to load, if we want to load file from LFS local file system to Hive table. What is the query? What you'll have to write in a Hive cell. This is one option Hive has given, and there is another option Hive has given to us. This is point number 1. This is 2. If we want to load file from HDFS Hadoop distributed file system to Hive table. This is another query. Okay, so again Hive cell, just one single line difference in my query. So both option is there, unlike MapReduce, because MapReduce strictly say I can only run parallel computation and distributed job when input is available in this space. Then only I can do this. If input is available in local file system, MapReduce cannot deal with the parallel computation and distributed operations. Okay, so this is one thing to remember in Hive and MR. I cannot differentiate between both because MR is one processing tool, Hive is a warehouse. So Hive is actually using MapReduce to submit their query. When I submit the query, I will come to the architecture. I have not yet discussed any architecture of Hive, but I'll come just in a while how the Hive architecture is actually working. And one question I'll give it to you guys for assignment. Now, here I will write load data local in path. I'm writing this in Hive cell, double sure. Do not write this in normal terminal. Load data. Since I'm loading it from local file system, that's why I'll use here a keyword called local. Load data local in path. Load data local in path, and within this single quote, I will define the path. Can I see where is my path in my actual system? So my path is this. Can I use pwd? home Cloudera and the file name, which is sample.txt. So here I will write that address, home Cloudera and sample.txt within single quote. Okay, load data local in path, location of the file into table name. And what's your table name? Table name is book, semicolon. Because semicolon, if you do not write, your code will not be, your query will not be executed. So to execute this query, this termination will have to write. Now, if I want to load from HDFS, if my input is available in HDFS, then I will write this query. Load data in path, and in that case, this input is stored in HDFS. What is the command to put the data from local to HDFS? That's -put sample.txt, and let me write this in root directory. Once this is done, you can recheck again that validation is always important, guys. Do not just run a query and come back to cell. Check whether the output is present in your HDFS directory or not. I can see this. All the sample.txt is there. Okay, all information is there. Now, second point. So I'll give that path, load data in path, and within the single quote, I will write HDFS path, which was sample.txt into table name. Literally, if you check this query, number one and number two, you just found one difference, that here I'm using one extra keyword local, and that's it. Here I'm not using any local keyword because this is taking all the data, all the file from HDFS. Let's do this practical. I'll check for first one, then I'll check for second one. Okay. Load data local in path. I'm currently taking it from local file system. Load data local in path, and don't just write a file name. I've seen people making this mistake. Okay, if you do this mistake, what will happen? Your system is unable to find where exactly this directory is. Suppose you are running this sudo hive. Suppose you're running this sudo hive command from here, from home Cloudera, then it may work. But if you're running this command from somewhere else and trying to access the file from download folder, and you're just giving the file your file relative path, not the absolute path, this may give you exception. So what is the recommendation to avoid such a mistake? And then just you'll be troubling and searching this exception error, why the problem is coming. Problem is coming just because the path you are defining is not correct. Always best practice, I feel, you should give absolute path. So whenever any thought comes, okay, can I give a relative path? If you're so good in concept of Unix and you know that, okay, if I'm giving this path, it can read it from here, you can give relative path. But if you're not sure about it, always give this absolute path. Into table name, and table name is my book. Enter. This will just take us 2.45 seconds. Now, if I have billions, millions, trillions, gazillions, any data set, it will just take 2 seconds to 3 seconds to load this data. And this is the reason we're calling Hive schema on read. MySQL is a schema on write. While writing the data, they checks the query. We have seen that point as a difference between SQL and HQL, which is a Hive query language. But still currently my all the data is correct. If I do not write the correct data, still it will take it. I will come to all the example one by one. Now, can I see this data in my Hive table? So select a star from table name. Perfect. This took me 0.806 seconds, fetched one row, and this is the line. This is Hive testing. Presently, Hive is terrific, warehousing management, provided by, etc. Now, guys, once this information is there, so your data is loaded in Hive, and you can run all the TML operations. But before that, I want to run some desk command. When I'm writing desk book, it gave me column name and their data type. Can I get extended information? So I'll say desk extended book. When I call this desk extended book, it actually brings me few more information. I'll read this in English. Table name is book. Database name is PRWA. Owner is root. Okay. Then schema, field name is dummy. Data type is string. Comment we have not given anything. Location. Input internal table takes by default data. Okay. If you watch my yesterday video, you'll see that I have specified this directory that internal table data goes to user Hive warehouse. And this is the database name. This is the table name. I'll go to this directory also. Input format. So by default, Hive uses text input format. By default, Hive will store this data in text format, and output is also text output format, text input format, and text output format. So this is a by default. You can use a different serialization and deserialization concept to store the data. This is the by default technique. Output format, compressed, false, because we are not using any compression technique here. Number of buckets, we don't have anything. Buckets will come. This is advanced concept of Hive. SERDI info, serialization, deserialization. Do we have any SERDI information? This is null. We're not serializing anything. It's a simple SERDI. Okay. Lazy, I'll come to this lazy. Lazy I will tell you right now, but advanced part of lazy we'll see in Scala programming language. Lazy is available in Python also. I think Java has also introduced from 1.8 point something. So lazy is one terrific concept nowadays, I feel, especially with the big data. Parameters, bucket mapping, storage, partition keys, parameters, number of files. We have just one file. Then transient last DDL time, this is the total transaction time, column states accurate true, total size 105. How can I check that? This is the total size of file. And if I go to my file system and check the size of file, it must be this byte. Any other thing? Table type, manage table. So please read this whole information, guys. If you start reading this log file and you start getting exception again, so just to reading the one log file can make you make your query clear for multiple log files, multiple monitoring tool you can check and see what is their status based on just if you know this log information, how to read them. Enough in desk extended table name. There is one more query for structure checking, and that query is so create table and table name. What is table name? It's book. So create table name book. If I say create table book, dummy is my column name, string is my data type, SERD, serialization, deserialization we are not using currently, we are using a lazy simple SERD. Okay. Serialization and deserialization, if I just say in a one word, okay, if I just say in one word, serialization and deserialization is a concept of Java. It actually came with Java, and now this concept we are using in a Scala and in other programming languages also. I have used this a lot in serializing my file using different format to convert my object. Okay, to convert my object. One sec. To convert my object into byte stream. Into byte stream. That's what I can say. This is about serialization. And why I'm doing this, because it can be readable from multiple programming languages. If I have serialized my input file using some file format, I can read it from Python, I can read it from Java, I can read it from Scala. I just need to create an API. I just need to create a bridge. And using that API connection, I can jump from one to another server using just this programming language. Okay, so it is making your job easy again. Serialization. And to read this serialized output, okay, to read this serialized output, we have deserialization. Same concept of encryption, decryption, same concept of compression, decompression, serialization and deserialization. Deserialization. So deserialization and serialization we have seen there also in Hadoop, right? It's a core concept of Hadoop also. So deserialization is just opposite of this, converting byte stream into object. Converting byte stream into object to read the file, right? This is what I can say for serialization and deserialization. And altogether, this both thing is known as SER taken from this and DE taken from deserialization. Together we call this as a SERD. So there are many types of SERD. Lazy simple SERD is one small thing, a basic thing by default one. Text input format by default, location where this data is getting stored. This is the HDFS directory location. Metadata I have shown you already, where metadata data is getting stored and appended in MySQL. This is in HDFS. I will visit this in a while and I'll show you this data. Number of file 1, total size, transient detail time, and etc. So you're getting the same information actually. This query and this query is very similar information they're giving me, but this looks clumsy, right? This is a scattered data. You cannot read this well, but this is giving you proper information in a DDL format. It is like if I copy this statement, okay, let's say I copy this statement from my machine and I pass this to you guys in mail. If you just copy this in your cell, your table will be created. You're not putting extra effort to write create table name and another statement, just copy and pasting. So this is giving me proper DDL, proper definition of my table. I will go now to tell you about lazy. I feel lazy concept you should know. So lazy is working this way. As the name suggests, the function itself is lazy. So if you say I have an input x is equal to and you want to create one array, let's say, okay. You said you're 1, 2, 3, 4, 5. Let's say you want to read a file, okay. Do not worry about the syntax currently. That what is array, what is this? Everything I'm coming. This is one array creation, or let's say I'm saying x is equal to, or maybe x dash is equal to, um, x dash is equal to, uh, I'm reading a file. So to reading the file in Scala, what do? I give a package that is scala dot io dot source dot from file I promise guys, I'll tell you everything this when I go to Scala. Okay, I'm just focusing on currently the logic. Don't see the syntax what I'm writing. Scala.io.source.from file, and there I'll give my file name. Suppose I'm giving a file name which is not present, which is not there, which is not available. Okay, let's say I'm giving in a single quote or double quote, because the string can read from both. Home Cloudera. This is the location of file. Home Cloudera and slash home Cloudera, and I'll give file name as sample new.txt, which is not there because my file name is sample.txt. I just give this location and try to read this. What this lazy says, I will not immediately compute this. Lazy actual concept is I will, this definition is given by lazy to you. I will not immediately execute this. Not immediately execute this. Then when you'll execute this? When you ask me to execute this. I'll not when you submit, because what happened in basic data type creation, if you say integer j is equal to Java in Java terms, if you say, or in Scala if you say well t is equal to Scala, and if you say p is equal to Python, this is from Java programming, this is from Scala, this is from Python. Okay, syntax is different, logic is exactly same. I'm trying to assign one string value to this variable, which is variable j. I'm trying to assign Scala value in my variable called t, and I want to assign Python to p. This is what my agenda. But the moment I run this command, immediately it will execute, right? What is happening when you're saying this? This query is immediately going to CPU, your core processing unit, processing it, and whatever intermediate output is coming for this J, which is Java, this will be stored or referred somewhere in your RAM, which is a memory location area, right? Same thing will happen in Scala also, in Python also. So they store your input file, input data, input record to RAM for time being processing. Once this is done, you can store them, and this RAM processing will be terminated from there. It will be destroyed from there. So RAM is for temporary storage. This is not a permanent storage, right? We know that this RAM is executing things faster. But when I run this command, I repeat again, it is immediately going to CPU and executing the space of CPU utilizing some space in memory management area, which is given by this RAM. In the case of normal query, okay, the same thing happened. Let me tell this in MySQL. If you go to MySQL and you run this select star from table name, okay, if you're getting difficulties to understand this data type, let me take the same concept uh, in MySQL or any RDBMS. You say select star from table name, which is people, where city is equal to Pune. If you give this plain query and you are saying that I want to get the all result related to city called Pune, the moment you submit this query, immediately this query will go. This is the internal operation. Immediately this query will go to your database, wherever you have your database server located. It will pull the data to their centralized server and process them using your core processing unit. Whatever data this people is having, if this people has total data of 500 MB, let's say this people table total data size is 500 MB, and out of 500 MB this Pune result is only 100 MB, right? So what is RDBMS doing? RDBMS is loading the whole data first, okay, sending this complete information to your CPU, filtering data related to Pune filtering related information to Pune, and then storing this intermediate output in RAM or hard disk, whatever the concept of query works. Okay, intermediate output there is storing in hard disk or RAM, and then you're getting the output as whatever output is there related to this table. This is what happened internally. But I don't want to submit immediately. I don't want to send this to CPU immediately. I want to store somewhere in my RAM area only. I don't want to send it to immediately to any core processing unit, and that is why I am talking about this lazy. It is like, let's say you are, if I use a metaphor, you're coming to the classroom, okay? You enter to a unit, and you have a big bag, just like a school people have a bag. Okay, this is your office bag, let's say. In this bag, when you enter, you have 5 books. In this bag, you have kept your 5 books. Okay, and you're keeping this bag. You're keeping this bag in reception. So when you're coming to office, having this bag, 5 books inside, you're keeping this bag outside the reception. You're not taking this in classroom. When you're not taking this in classroom, okay, you're just keeping this in reception. When I ask you, okay, so today we are going to discuss about this concept. In classroom, when we started the lecture, I'm saying today topic is going to be Hive, and this 5 books are related to Hive, Hadoop. Okay, separate book are there. Hive book is separate, Hadoop book is separate, Scala book is there, Python book is there, and Java book is there. Now today my topic is Hive, so I ask you, okay, can you go back to your reception point where you have kept your bag and get the book which we are discussing today? Just get me this Hive. I don't need other books. So you'll go back from here, you'll go to reception again, you'll take this Hive book, and you'll come back. And then you'll say, okay, this is a Hive book, and we can start discussing about it. This is exactly the lazy is working. Lazy says, I will not take all the element immediately. If you ask me to pick that data and ask me to process, I will process that, not the whole set of information. Because if you think logically, if I take all these things, I'm taking the metaphor this, but if you have this array 1 to 1 to 5, if you execute this immediately without looking how many elements are there, if you execute this immediately, then what will happen? It will go to process this data. It will keep first in RAM all these 5 element and process in CPU, and then give you the output. But don't you think this is misuse of CPU? Because suppose if I ask you, create an array with 5 natural numbers or prime numbers, okay, 5 natural numbers, and give me only the odd numbers. If this is my requirement, I'm saying you create one variable, keep 5 natural numbers which starts from 1, because natural numbers start from 1, 0 is not a natural number. And give me only the odd number, which means I'm asking you, I need 1, I need 3, I need 5. But the moment you run this, x is equal to array 1, 2, 3, 4, 5, because you'll have to create 5 natural number, my RAM will take all 5 element in a space of caching, which is obviously a volatile, but it will cache this all 5 and send this all 5 to CPU for processing. But I don't want to use this complete RAM area for all the element. I only want to use for 1, for 3, for 5. And to achieve this, I work with a lazy. So if you understand this metaphor, right, how this thing is working, the same way this is working. In nutshell, I can say lazy is helping me to get the element only which I want to store in a RAM or want to process in a CPU. I'm not unnecessarily taking all the input and sending it to CPU and RAM. This is a This is an optimization area. This is not a code writing area. This is your optimization area. Very important task, especially in the case of trillions of data if you're processing. And why this whole concept is there? Why we are talking about so many new concept in big data space or Hadoop space? Because guys, again, you're not handling 1 GB, 10 GB, 5 GB data. You're handling a terabytes, petabytes, exabytes of data. So if you're handling petabytes and exabytes, more than code writing, optimization is more important. This is what industry needs today, because data volume is getting high and high, and we, over the period of time, we have seen time increment, but uh, time memory increment we have seen, but time decrement we have not seen. How can we decrease the total execution time? We need solution for that. So this is the one of biggest concept in programming language nowadays, I will say, especially for big data programmers. And Hive has already inbuilt this theory, this concept for you. So that's about lazy more. I have given you one insights of it, okay, one teaser of it. When I go to Scala, I will prove this. When I go to Scala, I will prove whatever I'm talking. How I'm taking this three values, I'm ignoring this even number because I don't need even number. My question itself is saying, let me write the task. My task is this: create 5 natural numbers and and uh, find out find out odd value and square them. Let's say this is a task. If I want to write the code for this, I'll say, okay, can I say x is equal to array 1, 2, 3, 4, 5. Again, I'm into space of lazy, okay? I said x is equal to array 1, 2, 3, 4, 5. Now, next I said, I want to get the odd value only. So, we know odd value we can get using, I'm using a filter operation here. I'll say filter and y modulus 2, with this y is a lambda. We'll see lambda also. Y modulus 2 is not equal to 0. If any element is dividing by 2 and it is not equal to 0, then it's a odd value. If it is equal to 0, this is a even value. This is a core logic of your uh, odd finding and error even finding. Now, when I say this, okay, if I prove this also, so let me take 1 modulus 2. If I talk in Vedic maths, okay, I go to like school times and see this, okay, 2 is divided by 1. What is a reminder? Obviously, this is going to 0 times, and 1 itself is a reminder here, right? If this, I get 0 point, 0 point something. But whenever you divide the smaller value, as in when numerator is a smaller, when numerator is a smaller than denominator, okay, when numerator is smaller than denominator, we know the remainder is going to be numerator only. It's going to be numerator only. Now, similarly, can I check for this 2? 2 divided by 2, 2 divided by 2, do you get any remainder? Remainder is nothing. That's a 0. It's completely divisible. If I check for 3, 3 by 2, I'll get 1 remainder, because 3 minus 2, 1 remainder. 4 is again completely divisible. Then 5 is again having remainder. So in order to using this concept, what I'm getting value of 1, 3, and 5. And then I'm saying I want to square them. I'll say perfect. Let me write another function, map, and we'll see x is equal to x into x. Uh, don't worry, what is this? What is this? But if I make this lazy, if I write here, this is lazy, x is equal to array 1, 2, 3, 4, 5, what will happen? It will not store this array in my RAM. it won't compute immediately. Okay, it will take a space, but it won't compute immediately. It will compute when I actually ask to compute, and I'm asking only I need this result, this result, this result. I don't need this result. And I'm taking example of 1 2 3 4 5. How about if you have millions of input? Then your system will give you better performance. Okay, so this is advanced part. Okay, but since this is coming in Hive, so I thought to tell you. If you did not get it, that's okay. We'll see that part in Scala uh, with some real-time coding when I write this code in Scala cell. So excuse me if you did not get this point. That's okay. We'll see. We'll revisit again this chapter. After lazy, anything else? Okay. So this is how my record is looking in Hive, and there are multiple input format. Currently, I'm using text input format. Now, can I see this record in HDFS? Can I see this result in HDFS? I'll copy this from here and open my target directory. HDFS, DFS, -ls. If you want to go one by one, that's your choice. But to avoid the mistake, you can copy from there and paste it here. Can you see that file is there, sample.txt? And I will read this sample.txt and using cat here. This is one line in the same data which I'm reading from Hive cell. Okay, so two things is proved. Hive is using HDFS storage to keep this data. This data is present in HDFS, and metadata is present in MySQL. So 2 point is proved. Can I check third point? If I drop this table, my data metadata both gets deleted. Let me drop this table. Drop table and table name, which is book. Can I see table? Table is not there. And can I see this record? This record is also deleted. Can I go back to my MySQL and check, do we have this? This is also deleted. So metadata, data, table, everything is deleted because this was the internal table. We have seen load operation. We have seen DDL operation. We have seen few more queries on this.